working of PN junction diode as a half-wave rectifier. Working of PN junction diode as a half-wave rectifier. For that we have to draw the circuit diagram. Again, input AC source is applied at the primary coil of step down transformer. This is input AC source which is applied to two terminals P1 and P2 of primary coil of a step down transformer. And this is what input AC source. This is input AC source. And at the input, we can draw this type of waveform. This is positive half cycle and there should be negative half cycle. This is positive half cycle and this is negative half cycle. O is the origin, Vi is the input voltage and T is the time. And this is input alternating voltage, at the input alternating voltage. And this is positive half cycle. And this is negative half cycle. Negative half cycle. And this is the secondary coil having two terminals S1 and S2. S1 and S2 are the two terminals of secondary coils. Mutual induction occurs, that's why you can denote these two vertical straight lines which indicates that mutual induction occurs. And this is what step down transformer. Step down transformer. PN junction diode. D1 is the PN junction diode, and here there will be only one PN junction diode. And here at the output load resistance RL is connected. load resistance RL is connected. This is the output. Output is measured across the load resistance RL. And we can draw input output waveform. Output voltage across the load resistance RL is V0, is plotted along vertical axis. And time is plotted along horizontal axis. And at the output only positive half cycle, negative half cycle will be removed or will be blocked. Due to positive half cycle, we get positive half cycle. This is positive half cycle at the output. Positive half cycle is obtained at the output. Alternating direct voltage is obtained at the output. This is the alternating direct voltage. Output direct voltage is obtained at the output. This is the diagram of full wave rectifier. And output direct voltage is obtained across the load resistance RL. Across the load resistance RL. And at a certain moment P1 will have negative potential, P2 will have positive potential, S1 will have positive potential, and P2 will have here positive potential, and S2 will be negative in nature. And again we can draw input and output waveform. Below this what we can write? Input waveform. Below this we can draw input waveform. We can draw input waveform. This is the origin. At the input, input voltage is denoted by Vi, who is the origin. Time is plotted along horizontal axis. Now we can draw input waveform again. This is input waveform one, which is in which input alternating voltage is plotted against the time. Against the time. This is positive half cycle. Then we can denote negative half cycle. Again we can denote positive half cycle. This as positive half cycle. Then a negative half cycle can be denoted. This will be negative half cycle. Again positive half cycle is can be plotted. Below this we can draw output waveform. We can draw output waveform. Below this we can draw output waveform. Along vertical axis, output voltage across the load resistance is plotted. That is output voltage VO, and along horizontal axis, time is t. Time t is plotted. Time t is plotted. Now we can denote the scale of time or range of time. Within this range of time, positive half cycle will be confined, and within this span of time, negative half cycle will be confined. Similarly, we can draw second say a positive half cycle that will be confined within this interval of time, and second negative half cycle will be confined within this interval of time. Third positive half cycle will be confined within this interval of time. At the output across the load resistance RL, we get only positive voltages, and there will be no negative half cycle. There will be no negative half cycle. All the negative half cycle will be blocked by the diode during negative half cycle at the input. And here in a single diagram we can draw input and output waveform. Input and output waveform. This is the circuit diagram, and here what we can write: during positive half cycle, of the input, positive half cycle of the input AC source input AC source, comma, the terminal P1 of the step down transformer under bracket T. Here we can denote this transformer as T. This transformer T, and this will be the step down transformer. In some textbook, number of turns in primary coil and number of turns secondary coil are equal, but in this case number of turns in primary coil will be greater than the number of turns in secondary coil, and this is what step down transformer. And in this case, what number of turns, say number of turns in primary coil is NP, this number of turns, and number of turns of secondary coil is NS, and for step down transformer NP is greater than NS. NP is greater than NS. Number of turns in primary coil is greater than the number of turns in secondary coil. Positive half cycle of input AC source, the terminal P1 of step down transformer, becomes negative, and P2 is positive on account of mutual induction, comma, the terminal S1 and S2 of the secondary coil becomes secondary coil will become positive and negative, respectively. Hence, the P side of the diode D1, the P side of the PN junction diode D1, of the PN junction diode D1. The P side of PN junction diode D1 is forward biased, Sorry, as the P side of PN junction diode is connected to the positive S1 terminal, comma, the diode D1 is forward biased, is forward biased. Hence, what type of current will be flowing through this forward biased? Obviously, forward current I will be flowing through this forward biased, because this forward biased diode D1 offers low resistance or very low resistance. Low resistance or very low resistance, and this is what? Forward current. This is forward current. This is forward current. Therefore, forward current I flows through the diode through the PN junction diode which is forward biased, which offers low resistance. That's why forward current flows, which offers low resistance against the forward current. Hence, what positive output voltage is obtained across load resistance due to positive input voltage applied across the step down transformer. That means at the input if we apply output positive voltage will be obtained across the load resistance RL. This positive half cycle is applied At the output we get again positive half cycle. Positive half cycle. And this is what positive half cycle at the input, positive half cycle at the input. And this is positive half cycle at the output. That means positive half cycle is obtained at the output. At the output. Now we can explain what happens during negative half cycle at the input. And during the negative half cycle, during the negative half cycle of the input AC source, input AC source, comma, here we can denote P1 will become positive, terminal P1 will become positive, and S1 will become negative, P2 will have negative potential, S2 will become positive. During negative half cycle of the input AC source, P1 is positive and P2 becomes negative. On account of same words, on account of mutual induction, comma, on account of mutual induction, S1 becomes negative and S2 is positive. The PN junction diode D1, the PN junction diode D1, the PN junction diode D1 is reverse biased. And this diode offers high resistance. That's why reverse current will not flow through the diode. In this case we can denote reverse current. This is the reverse current I prime, and what will be the value of reverse current flowing through the diode? I prime will be 0. This is reverse current. This is reverse current. Reverse current. And I prime will be 0, or the diode D1 blocks the reverse current. It offers high resistance and this diode does not allow reverse current, does not allow reverse current I prime, does not allow reverse current I prime to flow through it, to flow through it. Thus no output, no output is obtained across the load resistance, is obtained across the load resistance, across the load resistance RL at the output. No output is obtained across the load resistance RL. Hence, what we can say, hence in the output, comma, we have the current, corresponding to one half of the wave, corresponding to one half of the wave, comma, the other half is missing, other half is missing. Other half is missing. Other half is missing. If we go back to the input and output waveform, that means we can draw input half cycle. This is input half cycle. Here we can write input negative input half cycle. This is negative input half cycle which is applied at the input AC source. Half cycle is applied, and also positive half cycle. This is positive half cycle, but at the output we should have only positive half cycle. This is positive half cycle. At the output, this is positive half cycle. At the output, but here negative half cycle is missing. That means one half cycle is missing. That means here what we can write, this cycle is missing. And this cycle is missing means this cycle is blocked by reverse biased PN junction diode D1. This cycle is missing. That means there is no negative half cycle at the output. Negative half cycle at the output.